At the first virtual Ifac World Congress, all plenaries and semi-plenaries are accompanied by an entertaining live element. This presentation is followed by a live panel discussion, where experts in the field recapitulate and debate on related ideas, questions, and open problems.
Well, ladies and gentlemen, dear Ifac friends and colleagues, I'm Janan Zaytoun, professor at the University of Reims in France and the immediate past president of Ifac. And it's my great pleasure to co-chair this panel live session together with Miyoko Nitsuma. First, I'd just like to thank the audience. I thank you all. And I'd also like to thank the World Congress organizers, and especially I'd like to thank Ifac President Frank Algauer. Organizing conference at this situation is not an easy task, and it's been successful so far. We enjoyed the plenaries and the semi-plenaries, and so thanks for this organization, and I wish them all the best. And I'd also like to thank our panelists who are with us today. We're going to talk about social skills for human assistive robots. And I'll just make a short presentation of the panelists. We've got the co-chair of the session, who was our semi-plenary speaker, Dr. Miyoko Nitsuma. She received the PhD from the University of Tokyo in 2007. And since 2013, she's an associate professor at the Department of Precision Mechanics, Faculty of Sciences and Engineering, Kyoto University in Tokyo, Japan. She's currently a vice chair of the Ifac Technical Committee on Robotics, and she was the program chair of the first Ifac workshop on robots control, ROCO 2019. She served as associate editor of IEEE Transactions on Industrial Informatics, and has received a number of paper awards. Our three panelists also, we've got Dr. Peter Korondi, who received PhD in electrical engineering from the Budapest University of Technology and Economics in 1995. And in 2008, he became a full professor of this university and doctor of the Hungarian Academy of Sciences. From 2011 to 2017, he was the chair of the Ifac Technical Committee on Robotics, and he also was the program chair of the Ifac Symposium on Robot Control, Sirocco 2012, and the local chair of the 2018 edition of this conference. He also served as associate editor of IEEE Transactions on Industrial Informatics and received many paper prizes. The second panelist is Adam Lucy, is the head of the Department of Ethology at Otvos Leonard University in Budapest. He's also the director of the Institute of Biology. He is the founding member of the Family Dog Program, which was the first in the world to deal with the scientific study of relationship between dogs and humans from an ethological point of view. His name is associated with the founding of the field of ethorobotics, the aim of which is to create robots that act as partners in human environments. And finally, we've got Dr. Vicente Matlan, who received his PhD in computer science from the Technical University of Madrid. And he's associate professor at University Rey Juan Carlos in Spain. Since 2008, he's a full professor in mechanical computer and aerospace engineering department of Université de Lyon. His research interests are centered around the themes of our panel and the generation of autonomous behavior in service robots. So I'm looking forward to an exciting panel, and I'd like to invite the co-chair Miyoko to say a few words.
Okay, thank you very much. Thank you, Jana, for kind introduction and chairing this session. And thank you all very much for attending my semi-plenary talk and this live session. So I'd like to thank organizing committee for this, for giving me this opportunity. So let's get started.
Okay, great. Your semi-plenary session was really exciting and inspiring. So it's very interesting with a number of experimentation. What we've seen about the robotics behavior was also exciting and very promising. But all the experiments that have been carried out, they were conducted under more or less controlled or semi-controlled environment with limited interaction patterns between the human being and the robot. So the main question that we have to deal with in this panel is, what are the main challenges that we have today to be able to generalize these behaviors to real-world conditions and not just to laboratory conditions? And as you know, in real-world conditions, you've got uncertainties, you've got multiple interactions, and so on. So the floor is open now.
Okay, thank you very much for your question. And of course, so that we needed a lab condition because we needed to evaluate robot behavior, and we need to investigate the necessity or how the behavior works. So that's why, so as a first step, we need to set up the lab environment. But of course, so as you said, so we want to extend the robot to use everyday assistance for humans. So there are many challenges remaining, as you said. So, but this is a very difficult question to answer because the answer might be related with all the questions that I want to ask to our panelists today. So shall I begin to ask a question to the panelists? So let me ask the first question to Peter. Could you introduce the concept of robotics and how it is important when aiding the human activity in real world?
Okay, thank you. And first of all, I would like to congratulate to your presentation. It was really excellent. So robotics is a new interdisciplinary field of science. It is not exclusively an engineering field, but requires the close cooperation of ethologists like Adam, who is here, and robot specialists and computer scientists. So nowadays, the robots are close to the technical level when they can venture out of the standard industrial environment into our daily life. Both robots and society need to be prepared for this. It goes beyond the fields of engineering competency. That's important. If a robot appears in the life of the family, the robot must adapt to the habits of the family. It means the robot must be socially integrated into the family life. One way or another, but the robot has to become a member of the family. The main question holds, like a human being, it might be ended by the Terminator, or answer is different. What we need, the robot must serve the human being. It must be the best friend of the human. The robot have to be faithful to human. But we have something similar. It is the dog. Anyway, Adam usually has a question, which was the first robot? He will answer this question. The basic concept of the research, the social robot is considered as a new artificial species. They are able to be integrated socially into the family life. Ethologists are setting up ethological model, verbal model, by examining the interaction between the dog and the man. This verbal model is redefined by computer scientists into the language of mathematics using fuzzy interpolation techniques, and thus, in this way, the behavior patterns are implemented in the robot. Robots are able to express emotions using abstract images, robot body languages, sounds generated artificially based on biologically phonological patterns. And the first complex behavior, which was described in this way mathematically and which was implemented experimentally, was attachment behavior. So we have a robot which is attached to the owner. And maybe one more answer. So, you know, when you grow up a child, you have to do gradually. So first you have to teach them how have you the robot greet the adult, and we need a long time to grow up a kid. I know because I have two adult boys, and we are in the same in the robotic field. So maybe our robots as at the childhood, from the point of view of social behavior. So they are not socially integrated to the society. Okay, thank you.
Thank you very much. Okay, so thank you, Peter. Let me ask the next question to Adam. Could you please add the potential of ethological study or state-of-the-art ethological study in terms of social skill design of robotic agent to make the robot behave in real environment, real interactive situations?
Okay, thank you very much for the invitation, and I'm really happy to share my views with the panelists and the whole audience. I think Peter already gave a nice introduction to this topic. Basically, I think Robotics just wants to make or provide a different perspective on how social interaction can be planned or designed between humans and robots, because we have so many examples where non-human beings, in our case, it's often a dog, that is interacting with another human. And social robotics, I would say the traditional approach to social robotics was that the only role model for the robot is the human. The human, there's a problem because humans have a very complex behavior, and also complex thoughts, complex emotions. So especially at this stage of social robotics, where although we have the robots around, but they still have limited capacity, both in terms of hardware and in software, I think the human is a little bit too complicated model or source of information that we could use. So therefore, for robotics, I like to say that animals provide a much simpler system as a model. So in our case, for example, which I really like is what Peter also mentioned, the attachment model. So the idea is that we can make a robot looking attached to a human just by controlling their approach and distancing behavior. This most of the robots can do. So for a robot, it's not easy, but they can actually control it for how close they approach the human, how fast they approach the human, what they do if there's a human in the room, as you just actually also showed in your presentation. So this is a concept that was derived from robotics, and already if you would ask the human, as you also did, Mihoko, in your studies, you could really found that humans are not just perceiving the distancing behavior, but they also attribute some emotions to the robot, whether it's they like them or dislike them, or how it relates to another person in the room. And the same concept can be applied in terms of communication as well. So what is one field that is I seem to miss in this interaction is the non-verbal acoustic communication between robots and humans, where you can also express emotional states of the robot just by manipulating the sound output. And actually, we recently published some studies showing that even that artificial sounds that were designed on the basis of animal communication can be very nicely used and effectively used in a human-robot interaction.
Okay, thank you very much sharing your thought. Okay, okay. So let me ask the next question. Vicente. Vicente, you are working. Hello. You are working on the generation of the autonomous behavior in service robots. To generate the robot's social behavior in real world, I think the design of cognitive abilities for the robot is also very important. So could you please give us your opinion about the necessity of socio-cognitive abilities for robots when they are assisting people in everyday environments?
Yeah, okay. Thank you. Thank you very much for your invitation to participate in this panel. I will try to give you a brief answer because some of my colleagues have already given you very good clues about this issue. I think that the robotics community has made a lot of progress on mechanics, electronics, even in robustness of the hardware platforms. If you see current state-of-the-art robots, I mean humanoid robots as Atlas from Boston Dynamics, they have amazing mechatronic abilities. On the software side, we have also made a lot of progress in the last years. We have developed almost quasi-standard frameworks as ROS, lots of libraries for solving classical problems. So in the end, we have reliable hardware. The classical localization navigation problems of robotics are solved, but however, we don't have social robots in our everyday life environments. And I think it's because we don't have been able to solve the cognitive part of the problem. On one hand, I think that we need to keep working on how to organize these abilities of the robot, which is the classical problem in artificial intelligence and robotics known as cognitive architectures. But on the other hand, in order to make this architecture work, we also need some bricks. And those bricks are those socio-cognitive abilities. And I think that looking at ethology is a really good idea because this branch of science has been studying these bricks for a long time in different species, and in dogs in particular, for instance, that are very close to humans. So these kind of bricks, these kinds of social cognitive basic abilities has to be developed and put available to the community to develop these social robots. In my group, for instance, we have been working on some of these issues. In particular, for instance, we have been working on context awareness in robots and how to develop this basic context awareness capability to be able to create robots that can improve some of the basic behaviors that Adam mentioned, for instance, in the problem of proxemics that has been studied in ethology for a very long time. And this kind of basic bricks that I would like to call them that way, I think that are one of the big necessities that we have to solve if we want to solve these social robots problems. Thank you.
Okay, thank you very much. So, okay, thank you
sorry,
very much.
Adam, you haven't answered, which was the first robot, which
yes,
was created by the human being. So
well,
it
yeah, I mean,
means we
yeah,
need yeah.
Well, that is sort of a joke, but especially if you talk to biologists, maybe they are quite surprising if I tell them that, according to my views, the first robot is actually the dog that was already designed, sort of speak, or selected for by humans more than 10,000 years ago. So actually, we are familiar with sort of robots that are very different from us, despite of the fact that actually we can cooperate with them very well. So even just as Vicente mentioned, there is a role model for social robots around us. And even I would maybe debate whether the mechatronics, although it's quite well established, is as good as the mechatronics of a dog is. But I also know the argument that biology had billions of years to establish something. So why would we expect from engineers to be so fast? But yes, so I think this is a very interesting aspect. And also to add what Vicente was mentioning, so the other issue with this cognitive part is, I think, where there's some limitation is the perception. So we have good cameras, we have good ears, I mean, microphones or loudspeakers, but the organization, how the awareness of the robot, of the actual environment should be, and how the hierarchy of these should be organized, that is also a very critical issue. And we face this problem each day when, because the robot can only do what we program it for. So this is a limitation, at least.
This is the part of the cognitive architecture I was mentioning. This is one of the two issues. One is to create those basic bricks. We have some of them in the engineering part. We are developing some on the perceptive part. And we have been discussing in artificial intelligence for more than 40 or 50 years, this cognitive architecture. And this is a really big problem.
Yeah.
Well, great. Thanks very much for sharing your views and insights on our topic today. I'd like to have one specific question. It will be for Adam, and then one general question for all of you to try to wrap it up. So the specific question for Adam, after hearing what you've said, there's something that you've mentioned about the distancing behavior. And, you know, today we're only talking about distancing behavior with the COVID situation and so on. Would that have any implication on the way that these robots can learn how to adapt when they see that the humans cannot interact directly now because they have to be distanciated from each other? Or
Well, I'm not sure what you mean by this.
I don't know neither what I mean, but I mean, this is something that triggered that question.
But I think actually it's not really, my answer would not about the robots, because obviously for robots, the distancing is less important than for the case in the case of humans. The problem is actually more in our society, because I am as an ethologist also dealing with this distancing problem, how artificial systems can replacing that sort of natural distancing behavior between us. So that we are now using, I mean, we're trying to use expressions. We're having a video image now, and that helps to understand the meaning of what we're communicating. But maybe, you know, the screens could move back and forward based on my behavior. So if you would have intelligent cameras that could mimic the distancing behavior even virtually, which I would see as a very interesting and new technology, by the way.
Oh, interesting. The general question to all of you: what are the most important future challenges of social robotics? So I know that you have different perspectives on that. So let's start with Peter, Adam, Shante, and then Miyoko can conclude.
Yeah, so I think we have to grow up the robots. So I think from the point of view of behavior, so I really in the childhood. So we have to learn a lot from the dogs. I mean, we have to learn from Adam's research. So they describe the dog human behavior, and maybe we have to transfer it to mathematics, and it takes a lot of time. So we always so what was happened, that Adam set some rules, we programmed it, and it turned out that something always missing, because the dog knows the missing rules, but when we program what we received from Adam, it turned out something missing, and it took us maybe 10 years when we developed this attachment model. So it really takes a lot of time to describing such models, such easy verbal motor to translate the language of mathematics.
Well, so it turns out that this is the ethologist's fault why social robots are not working. But anyway, my view would be, because I go back to Janan's first question, that we should now move from the laboratory to the real world. So making this transition, this is a huge challenge. And from the ethologist's point of view, I think the challenge is here to have robots that whatever they do it in a very special and reliable way. So I mean, they should be autonomous 24 hours a day. So they really provide those services, those behaviors, those interactions reliably. And this is what we are really looking for, because only on that basis can we observe robot-human interaction in long term.
Yeah, I agree with Adam. In my opinion, the most challenging issue is designing and analyzing those long-term human-robot relations. I mean, most experiments in human-robotics interactions last for a few seconds, minutes in the best case. How are social robots going to interact with humans in longer relationships is, from my point of view, the real challenge. One thing is a robotic appliance, and I think that social robots are a completely different thing. And these social relationships are only happening in long term. So the bricks that we was talking before are for very short periods of time. But if we want to develop real social etho robotics, we need long-term relations.
Okay, thank you very much. So I had all the questions, answers to answer the most important challenges to achieve the extend robotics from the lab, the very specific conditions to the real environment. So through today's discussion, so we saw that a lot of challenges remaining. We especially so we want to integrate the robot, socially integrate our human society, and also the robot behavior should be robust and practical and reliable. Interaction should be available. So interaction between human user and robot should be achieved to maintain or keep the long-term interaction and evaluation of the robot behavior. So I'm also very interested in implementing the robotics behavior into the everyday robot services. Then, so I want to investigate how people accept the robot behavior as usual. So that is my conclusion today's panel discussion. So it was a really great opportunity to share and discuss this issue to realize a human-assisted robotics. I'd like to thank the organizing committee again for giving us this opportunity. And I'd like to thank everyone watching this live session. I hope today's discussion will be fruitful and inspiring for the audience of Ifac World Congress. Finally, Janan, thank you very much for chairing this session. Thank you.
Thank you very much, Miyoko. And as you said, we had a real interesting discussion about this issue. Thanks for your views. Thank you for your insights. I'd like especially to thank Peter, Adam, and Vicente for expressing these different points of view. I'd like to thank Miyoko and congratulate her for the excellent semi-plenary that she gave today. Again, I'd like to thank the Congress organizers. I'd like to thank the audience, and I wish to all of you safe days ahead in these difficult times. Bye, and all the best.
Thank you.
Thank you very much.
Bye.